Hello, and welcome to the KISS Principles of Chemistry with Miss Kissinger. Today we're going to be talking about single replacement reactions. In order to do a single placement reaction, first we need to identify what are the reactivity series of each of the elements. So a sheet will be provided for you for tests, and you should have gotten one in class. What we'll notice is that we have a column of metals that are going from most reactive to least reactive, and nonmetals from most reactive to least reactive. In a single replacement reaction, we will have two different things coming together, and one of those things are going to swap. So if we have metals that are swapping, then we need to determine if the metal that's in the compound is lower, that can be replaced by a metal that is higher. If it is gases that are replacing each other, if it's a halogen that is solo, it will always replace any other gas. But if it is another halogen, we need to compare, in this case, which one has the higher reactivity. That will be the one that always wins in the single replacement reaction. In this example, we will use the compounds sodium chloride and lithium metal. As we notice, lithium is by itself, and lithium, if we look on the periodic table, is a metal. In this case, lithium can replace sodium if and only if lithium is more reactive. When we review the reactivity series chart, we'll notice that lithium is higher up in reactivity than sodium. So in this case, lithium can take the place of sodium. We also have to consider the charges on lithium and sodium. So both sodium have a +1 charge and chlorine has a -1. An ionic compound, like what we have here, must have a balance of the charges to equal 0. So in this case, we can have lithium and chlorine, and then sodium is displaced by itself. So this reaction can take place. If we were to take this equation and put it in the reverse, we'll notice that lithium chloride now is the compound and sodium is the metal by itself. On the reactivity series, lithium is higher up and sodium is lower. Because of this, no reaction can take place. So we would just say no reaction. When we talk about compounds and whether or not it's ionic or not, water is unique in the fact that hydrogen can act like a cation. And of course, our metals are always cations. So in a single replacement, a cation will always replace a cation. The easiest way to do this is to break apart hydrogen as HOH, meaning hydrogen and a hydroxide group. In this case, hydroxide has a -1 charge and hydrogen has a +1 charge. So we can have lithium replace the hydrogen. In this case, lithium will bond with hydroxide and hydrogen will be by itself. Now we have to remember there are 7 elements on the periodic table that are diatomic, which means that they must come in pairs. So hydrogen will never be found by itself. It'll always be written as H2. In this example, our equation may not be balanced, and we will learn balancing equations in another lesson. This example, we're going to look at single replacement where the metals have different charges. In this example, we have gold chloride, and it's actually gold 3 chloride because this 3 comes from the charge on gold, and chlorine has a -1 charge. Magnesium, we can look at the periodic table and find out that it has a charge of +2. In this case, magnesium is definitely higher on the reactivity series. Gold is at the bottom. It is the least reactive of the metals. So in this case, we must balance out the charges. So Mg has a +2 charge and chlorine has a -1 charge. In order for us to balance this means we must have 2 chlorines for every 1 magnesium. So we'll write it as MgCl2, and then this leaves gold by itself. Again, this is not balanced. We will review that at another lesson. In this example, we are going to go ahead and review what happens when sodium chloride reacts with fluorine gas. Fluorine gas, again, is one of the diatomic 7. So we need to consider fluorine as a nonmetal. And nonmetals can only swap nonmetals. So sodium or fluorine will replace chlorine and bond with sodium. In this case, sodium has a +1 charge and chlorine has a -1, and fluorine has a -1 charge also. So our new product would be NaF because it is a neutral compound, and what's displaced is chlorine. Again, chlorine is diatomic, so we must write 2. Here we'll look at an example of single replacement where the charges are different on the compound. So we have beryllium nitride. In this case, we can look to the periodic table and we have to remember that the numbers below do not represent the charges, but the number of compounds needed to neutralize the atom or the compound. In this case, beryllium has a +2 charge and nitrogen has a -3 charge. When we look at chlorine, which is trying to replace, we see that chlorine is a halogen, which will always replace another nonmetal. Unless we're comparing halogens to halogens, then we need to compare which halogen is stronger. Chlorine always has a -1 charge. So chlorine will replace nitrogen. We have to keep in mind the charges. So beryllium has a +2 charge and chlorine has a -1. So in this case, we will have BeCl2. And then our final product will be nitrogen. Then we need to remember that nitrogen is diatomic. So in this case, nitrogen would be N2. I hope you enjoyed this tutorial. If you have additional questions, feel free to email me or send me a message in Canvas. Thank you.